Morning students. Today's topic of our lecture is elements of digital communication from the subject digital communication system. Outline of today's lecture is learning outcome, reflection spot, elements of digital communication system, and recapitulation. Learning outcome. What is learning outcome? After the lecture, the students will be able to list the different elements of digital communication system, state the functions of different elements of digital communication system, and compare analog and digital communication system. Now, reflection spot. How the elements of digital communication system will differ from analog communication system. Students, think about it and jot down the points into your notebook. Take a pause for a few seconds and note down the points. Now let us start with the elements of digital communication system. The first block is discrete information source, source encoder, channel encoder, modulator. These are the elements of transmitter blocks. Then the information signal passes through the physical or the communication channel which connects to the receiver. Now the receiver has the reverse chronicle order of the blocks which are used at the transmitter end. So first block is demodulator, then channel decoder, source decoder, then your final destination, whether it is a loudspeaker or a display device, etc. So let us start with each elements of digital communication system. The first element is discrete information source. What do you mean by discrete? Discrete means the information signal will be in the form of symbols, or it may be in the form of binary data like ones and zeros. So an discrete information source generates information signal in the form of discrete, that is the symbols or binary form. But in general, the information source generates a message which may be in the analog or digital type, like your audio signal, audio video signal all comes under the category of analog. Your telephone signals, voice comes under analog. But the data, that is the files from the computer, email, etc. comes under the digital type. So if your output of the source and information source is analog, it has to be converted into digital by using proper encoding technique like pulse code modulation technique, adaptive delta modulation, etc. Now next, the output of the discrete information source is binary sequence. Now this binary sequence becomes the input to the source encoder. So when we use source encoder at the transmitter end, the compatible source decoder is to be used at the receiver end. So when we tell the function of the source encoder, we'll also cover the topic, that is the function of source decoder. So let us discuss source encoder. Now the source, what is the function of source encoder? Now the input to the source encoder is a binary sequence, or it can be a symbol sequence. If it is symbol sequence, the source encoder converts the symbol sequence into the binary sequence. The second function is, now there is a repetition of alphabets, and few alphabets always follows a particular alphabets, like U follows always Q. There are space in between. So we are not utilizing the bandwidth efficiently. Our data rate is not utilized efficiently. So we have to perform data compression technique also. So along the second function of source encoder is to perform data compression technique. So suitable data compression technique which compresses the data binary sequence into compressed data so that we can use the optimum utilization of bandwidth can take place. Now the source decoder which is used at the receiver is compatible to the source encoder which is used at the transmitter end. Now what are the functions of the source decoder? It performs the reverse process. First, if the data compression is used by the source encoder, it will use a compatible decompression technique, and it decompresses the data sequence into proper binary sequence and then converts this binary output of the channel decoder into symbol sequence, or it may be in the binary form also, depending upon the final output driven device which we want. Now the output of source encoder is in the form of a binary sequence. So the channel encoder input is nothing but your binary sequence. It takes the binary sequence and add extra bits to it. Now this extra bits does not carry any information. It is used for error control purpose. Why error control is needed? When the information passes through the channel, communication channel, noise gets added, or because of the properties or the characteristic of the channel also your noise will get added. So at the receiver, when you are retrieving the information signal, the errors will take place, and we don't like any error to take place because your information is going to change. So it adds the extra bits which is used for error control purpose. Now what does the channel decoder do at the receiver with those extra bits which are being added by the channel encoder? So those extra bits, the channel decoder uses those extra bits for error detection and correction purpose. So sometimes you have only error detection method. So in that case, acknowledgement is sent to the transmitter to retransmit the information again. But most of the application uses error detection and correction. So once the error is being detected and corrected, your extra bits are removed and you get a proper binary sequence corresponding to your information signal. So now the output of channel encoder is a coded binary sequence. So what does the modulator do? Now we use a digital modulator where the modulator input is in the form of a digital signal, so we call it as a digital modulator. Basic function of modulator is to convert the information signal into carrier high frequency signal. So it accepts the bit sequence at its input and convert into continuous time varying analog signal which becomes compatible to the communication channel. Basically your digital modulator functions is to make the information signal compatible to your communication channel. Now at the receiver, your digital demodulator is used, which is compatible to your digital modulator. If we use modulation technique like ASK, PSK, FSK, and if we use PSK, phase shift keying, then at the receiver, digital demodulator has to be your PSK demodulator only. So the demodulator extract the message from the received modulated signal. Now the output of modulator is nothing but your continuous time varying signal. So this continuous time varying signal, high frequency signal, propagates through the communication channel. So this depicts nothing but addition of noise because of the external source. When the signal propagates through the free space, some noise will also get added to it. So the communication channel is a medium between the transmitter. It connects the transmitter to the receiver, and hence for long distance communication your message can be received. So this channel can be your wired or wireless communication channel. Now wired means there is a physical connection between the transmitter and receiver. There are two types we basically use for long distance communication, that is RF transmission line and fiber optics cable. So RF transmission line you have already learned, where we use twisted pair for telephone lines, coaxial cables for CATV. Those are the examples of RF transmission line. Your LAN connection, your MAN connection. Then fiber optics cable uses a different technology where your information has to be converted into light if we are using fiber optics cable. So this is a recent development which provides a very high data rate communication, fiber optics cable. So we will see later this topic. Now next type of communication channel is wireless, where we use free space. So depending upon the bandwidth of the free space or bandwidth of the communication channel which is allocated for a particular application, your modulator converts the binary sequence into that particular high frequency signal by using particular proper modulation technique. Next is recapitulation. So we have discussed your digital communication system, all the elements. Now you have already learned previously your basic communication system, that we say transmitter and receiver, and there is a connectivity between the transmitter and receiver which carries the information, and hence we get at the receiver your information signal. Then we classified this basic communication system into analog communication system and digital communication system. You have already learned analog communication system in your previous semester. So here your information is in the form of analog signal, continuous time varying signal. Even the carrier is in the continuous time varying signal, even modulated signal is in the form of a continuous time varying signal. So we cannot use any signal processing technique over here. Your noise immunity is poor. We cannot use any data encryption technique so that the security level can be increased. So this all are missing in analog communication technique, and it cannot be used for long distance communication also, because if we use repeaters in between, then the repeater does only the function of amplification, nothing else. So signal, along with the signal, noise also get amplified. So you cannot use too many repeaters to elongate the length of communication. So we shifted to digital communication system. So most of the communication system now are shifting towards the digital communication system. So it is the need of the hour to study the digital communication system. Here the information is in the form of binary sequence, that is ones and zeros, and your modulated signal is continuously time varying signal. So since your information is in the form of ones and zeros, we can apply a lot of error control technique. We can use in order to increase the reliability of the communication system. Then we can use encryption technique, which increases security, and noise immunity is also very high. So digital communication system, we can use a lot of multiplexation techniques, where TDM, FDM can be used to utilize the bandwidth to its maximum level. Whereas analog communication system, we cannot use TDM, we can use only frequency division multiplication. So this is nothing but the complete summarization of analog and digital. Now you will be able to compare both the system. Thank you, students. Next topic of communication, we'll take a digital communication system. We are going to take is then the channels in detail, the communication channel. In order to make any particular communication system, we have to design the channel also. So please revise the topic and come so that you can understand in a better way. Thank you.